Tell me. Okay. So hello. I will introduce myself. My name is Ismael Bautista, as you can read, and I've been working on Moonbeam since March to October as a grant committee member. That for those who don't know what's a committee member, it's just like a group of people that manages the what grants are given to what teams. But that's not the important thing today. The important thing today is this presentation, that it's Crosschain DApps and blockchain interoperability with Moonbeam. And as this talk, it's a very entry-level talk. First, I will speak about what's blockchain. Then I will speak what are the apps, what is Crosschain, what interoperability, and I will finish with what is Moonbeam and how all of this integrates into Moonbeam. Okay? So at first, the first question that we need to answer is what is a blockchain? So to keep it very simple, a blockchain is a network of computers that are called nodes that are maintaining a database. And this database, I mean, just to keep it very simple, normally it's called a ledger, like in Spanish, a libro contable, where you save transactions of what kind of the amount of money that you have sent to one person or to the another. For example, you are Alice, and you want to send 10 coins to Bob. So what you do, you send like the message, you contact this network of computers, and this network of computers executes the message and says, hey, you are saying, okay, I want to send 10 coins to Bob. So he processes it, and he sends it to Bob. And that's it. And you may think, okay, this sounds like a normal database. You can do this with Visa or with any kind of stuff. Yes, but the key point with blockchain is that it has a few characteristics that make it unique for this. One is transparency. What does this mean? That when you send money to another person, everyone can see that. So there's no lie on there. You cannot say, hey, I did not do that, because it's clear, it's written on the blockchain that this acts as this. The second characteristic is that it's immutable. What does it mean? That when you send a message, when I send you some coins, you cannot change it. It's impossible. The third one is that this is decentralized. And what does it mean? Because this is a very fancy word. This means that all the computers that are on the network, I mean, are not controlled by, for example, Microsoft or Amazon or from this university. It's like a certain amount. You yourself can just put your computer and start processing messages and reading data and do like all this stuff that we have mentioned. And how can you make this decentralized, that everyone can join the network and work and produce work? Because it's secure by cryptography. So that's why you don't need someone on the behind, because you have cryptography to sign the messages and to verify the messages and to check that everything is working. And the most important implementation of blockchain have been Bitcoin. And Bitcoin, what it is, it's digital money. So it has a set of nodes, a set of computers, and you contact with these computers to say, hey, I want to send money to Bob. And then the money is sent to Bob once the Bitcoin network processes it. And you use the Bitcoin token to pay the transaction. So if I want to send you money, I will pay with my own Bitcoin to send you Bitcoin. And this is like the first implementation of popular, like of public blockchains. There was previous implementations, but it was not as popular as Bitcoin. But what happens with Bitcoin? That it's only for money. So what happens if you want, it's very, like it's for more stuff right now, but well, they try, but it's a discussion that it's very, very deep. But there's another blockchain that what it did, it's like make all this stuff, like all this message processing, a bit more complex. So now Ethereum, that is this blockchain, what it created, it's something called the Ethereum virtual machine, that if you are familiar with programming languages, it sounds like Java virtual machine, and it's something very similar, that you have this Ethereum virtual machine, you put it on the blockchain, and then you can send programs. So you are not only able to send Bitcoins, but now you can have your own your own tokens. That's why we have cryptos with dogs and with fruits and with all this stuff. Because now with Ethereum, anyone can create their own cryptocurrencies and anything that comes to your mind with some limitations, of course. And what happened with Ethereum? That a lot of applications came from this, mostly related to financial services. And these applications are called DApps, or decentralized DApps. So what is a DApp? I mean, to keep it very simple, I mean, this is a very broad topic, but to keep it simple, it's an application like the ones that you know, but that uses in some way or the other a blockchain on the back end. And it can also use another kind of decentralized services or technologies, but for now, to keep it simple, let's use the strict blockchain. So, for example, what happens with this kind of applications? If the application fails, for example, the front end, you go to the website www.ismael.com, and then I have an app that it's super fun, but it's on this kind of Ethereum virtual machine. So you can use, for example, if the front end fails, you can use the smart contracts and build your own front end. In a real world example, so for example, Uniswap, it's one of the most popular apps and one of the oldest. And what you can do is you can exchange cryptocurrency without going like to a normal, like to a controlled company, to understand ourselves. So for example, you go to Uniswap, you send your money to the blockchain, and let's say that you have Ethereum or you have USD, okay, and you want to buy Pepe. You know that it's a meme that it's from a green frog that also has a crypto token. And let's say that you want to buy some Pepe. So you go to Uniswap, you trade it for Pepe, and you get your Pepes on your wallet, and you buy for 2069 Pepe, let's say, okay, and you have it on your wallet. What happens if Uniswap falls? Nothing happens, because you can go to the smart contract and swap again the Pepes for the Ethereum. You need to have some knowledge, but you have the ability for that. If you buy Pepes in your bank account, I mean, it's very hard to do that, but let's imagine that you can buy Pepe in your bank account, okay? Then if the bank account, if the bank just breaks, I mean, it falls, you have no way to get back your Pepes. Maybe your euro, because there's another guarantees and all this stuff for banks, but not your Pepes. Okay, so that's one of the points of the DApps. Also, the incentivization. I mean, why can you just go here and buy Pepes? Because there's a smart contract that used to keep simple. This thing about smart contracts are just programs. Okay, it's programs that are on the blockchain. So Uniswap has a thing that it's called pool, that you get Pepes and get Ethereum and put them on a basket. That is like a pool. So every time that you want to buy Pepe, you put Ethereum on the pool and get like the amount of Pepes that it's related. So if you have, for example, USD, two kinds of euro Isma and euro Adrian, because we both give euro, it will be always €1, €1. You give €1, you get €1. But if, for example, if Ethereum costs 2,000 and Pepe costs 0 with 4 zeros, whatever, you will see that you will have a lot of Pepes for every Ethereum. So you will have a very big, tiny bag of Ethereum and a mountain of Pepes. And this is how Uniswap works. So if you put your money there and someone exchanges Pepe by Ethereum, then you get money, you get a fee from that. So that's how you incentivize people, or you make people to use your application, right? And there are more examples, like Moonwell, what is also related to financial services. And in Moonwell, what they do is that you deposit your money, and there's people that comes, gets your money, and does whatever they want with that money. They can buy Pepe and wait until they can sell it, and earn more money, and then they return the money. And when they return the money, they pay some fees. And that fees are the money that you get for depositing the money, because you are lending money, and there's people coming to borrow it and use it, and to return it, you earn it. And that's one of the points of the DApp, like, okay, It follows the principles of blockchain. It's hard to censor. It has mechanisms to self-sustain, but it's something very, it's something that it's very, how can I say, tied to every blockchain. So, for example, Uniswap, you can go to Ethereum, you can go to Avalanche, you can go to Moonbeam, but for example, if the pool of Pepe Ethereum, that pool, it's only on Ethereum. If you wanna buy, and if you have your money on Moonbeam, you need to move your money to Ethereum, buy it there, and then keep it there, because there's no Pepe on Moonbeam. It's a mess, and it's something that it's very bad for like crypto and all the blockchain stuff, because as a user, if it's hard to understand this stuff, if you need to interact with a lot of new stuff that it's hard, you really need to have like some kind of interactivity between all these blockchains, because let's say that you can buy Pepe here, go to another blockchain and sell it and earn money. So that's where this comes. So multi-chain is what I told you. For example, Uniswap on different blockchains. And Crosschain, what it is the ability to send messages or send this kind of data from one blockchain to the other. Because something that I didn't mention before, and it's important and I save it for this moment, is that blockchains are isolated networks. What does it mean? That you have a blockchain, let's say that you have here 3 computers, or any amount of computers, and they only have connectivity between themselves. So, for example, if you want to create a smart contract, a program that, let's say, a betting contract. So let's say that Real Madrid plays against Barca, and you say that it's a draw. I won't say who wins. So you want to say that it's a draw. Then you will need to connect, to be able to fetch that data, to get that data from the outside, but you can't. You need some additional infrastructure to be able to get that data. So this is one of the points of why do we need all this cross-chain stuff and all this multi-chain stuff, because one of the ways that blockchains are so secure is that they are just their own network, so they are not connected. And then there are solutions that allow you to do this. And here, it's where interoperability starts. And this is like where all the hard stuff, let's say it starts. So interoperability, as we see, is the capability of different blockchains, let's say of these different kind of computer networks, to communicate themselves. So let's, as an example, let's say that you are at your home and you have another friend and you want to play Age of Empires 2. That it's a classic game, okay? And you say, hey, I only have a local network and you have a local network and I want to play with you because there's no more servers. There are, but just as an example, okay? So you will need to have a way to connect your network, your computer, to his computer to be able to play Age of Empires or Counter-Strike or League of Legends, God save us. So with blockchains, what we have is different ways to accomplish this, because on the start, it was not thought. For example, the guy that created Bitcoin did not write anything about, hey, how does, someone correct me, something like, hey, this chain will need to contact with other chain. And this is something that it's now going on research. It just started on research with Ethereum. And how can we interoperate different blockchains? So for example, you can use a token bridge. That a token bridge is like you have your Pepe on Ethereum and you want to move them to Moonbeam, let's say. So you will go to a third party, let's say like a company that will do that for you. And how do they do it? Okay, you give me your Pepe, I have it lock it down on my wallet, and then I will give you the same amount of Pepes on that chain. And if you want them back on the other chain, you send them to me again on that chain, I save them, and I give you back. That's the way. It's like, okay, there's like no interoperation. Like it's not like if you send like a packet via TCP or do a ping or like something like that. It's not like that. So what happens with token bridges? That it can fail. And it can fail, and already happened, that there's people that, for example, move their Pepe, as an example, from one chain to the other. This bridge, for example, the CEO, well, or the owner, gets arrested, and then it's more common than you think. It's more common.
Today, the CEO of Binance.
No, but it's not. No, Binance happened this, but no, but that's like an exchange. That's like a normal company. It's like if you go, for example, to Revolut or to BBVA or Santander and buy this kind of stuff. No, I mean, this is like they have their own technology to like, okay, you send me the tokens on one side and to the other. And in this particular example, I mean, the people that knows about blockchain know what protocol I'm talking about. But what's happening is that, for example, you have USD, you have dollars, okay, a version of dollars of the blockchain. And this blockchain had a huge amount on one particular blockchain. What happened? This CEO got arrested, and that liquidity, that money, got stuck there. Because the guy that says, hey, this money, these virtual coins that really cost this amount of dollars, the guy's not there, he's just in jail.
The bridge gives you a copy of the token in the other chain, right? It's not the same.
Yeah, it's I mean, it's not like, I mean, it's a copy, but it's more like a wrapped version. Like, okay, you have a token, and you use wrap it in Web3 family, and then you have a Web3 family Bitcoin. Yeah. Okay, so I have Web3 family Bitcoin, and I go, and in this shop they accept Web3 this Web3 Bitcoin, and then I say, oh, but I need to give it back to Bitcoin because I don't know, I need to pay my hypotheca, and they only accept Bitcoin. Please. So you want to send it back, and to unwrap, I mean, there's no way to unwrap it because the guy that will give you like the real Bitcoin is not there anymore. It's very similar to with exchanges like Binance. In Binance, what it happens is like Binance, you buy your tokens, and you're buying it in a normal application. So you are not using the blockchain. You are using it because what you do is you buy the tokens, and then you move it to your wallet. Like, okay, I go to the bank, give me 20 euros, and you save it to your wallet. It's very similar. On Binance, you have it there, and it's like a promise of that if you want these tokens that you have bought, they will give you. Then it also happens that these kind of companies can fail, and then you lose the tokens. I mean, it may happen with everything. So why do we need interoperability? Because blockchain, I mean, there may be hacks, but normally the hacks are on the programs, on the smart contracts, are not at a protocol level. For example, Bitcoin, it had bugs at the start, but it was really, really on the start, like on 2010. You know, it was like on real on the start, but no one has hacked Bitcoin, no one has hacked Ethereum, no one has hacked anything, blockchain on that protocol level. So that's why we need to make something that it's, if we cannot make blockchains to go to the outside, we need to make the interoperability solutions to be like this, you know? I mean, to be secure, to be like blockchain. So what are the examples of interoperability in blockchain? One example is a blockchain called Polkadot, that what Polkadot is a blockchain of blockchains. So what they aim is like you have a network, and you can just create a blockchain and get inside. So you are like going a step deeper, because before you were getting a computer and connecting to a network, and now you are creating a network and creating it and adding it to another network. And why do Polkadot does this? Because then, I mean, the security, I mean, all the blockchains that connect to this main blockchain that is Polkadot share the same security, and they can send messages between themselves at the protocol level. So you don't need third parties, you don't need another company, you don't need Binance, you don't need another kind of stuff. Because you can just, with your code, you can just send messages to, for example, to a blockchain. I mean, you don't need to think, hey, on the future there will be a new blockchain that does this kind of financial service that I'm interested in. No, I mean, it's all, I mean, when they start on the blockchain, you can just connect to them. And the way that they do is with something called cross-consensus mechanism. And consensus sounds like a very fancy word too. It did sound for me, but consensus is just get to agreement with someone. It's like, okay, how do we are sure that what we have sent from one blockchain is valid on the other? So let's get an agreement. So that is what cross-consensus messaging. And this is like a native solution. There are other solutions. Another one is called Cosmos, that it's very similar, but you have some kind of blockchain in the center that's called the hub. And then if, for example, you want to create a blockchain, you just create it and connect it there. And then you can just speak to all the blockchains that connects to that hub. It's more or less similar. The difference is like in Cosmos, you can choose to what hub connect, and on Polkadot, you connect to the default hub, that it's the relay chain. And let's give you the example of Polkadot PPAR Chains before going deep into general message passing, because this is getting way difficult right now. Okay, so this is what Polkadot does. You see, it's a general format for blockchains to communicate, but this is inside Polkadot. So what it does is, for example, this is the Moonbeam logo, and what it's doing, it's sending messages to Polkadot. So for example, if you go to Binance and buy USD, and when you want to withdraw it to your wallet, it says Polkadot. So what you are doing is like moving it here, and from here, let's imagine that you have a lot of blockchains here. So from here, you can choose if going to Moonbeam, if going to another one that is called Akala, another one that is called Bifrost, another one that is called Astar. There's like a lot of blockchains that does different kind of stuff, but you always need money, and the money is like the same for everyone, right? So right now, I mean, I won't go very deep into the technical level of XCM, but what it does is, okay, I send a message to the Polkadot relay chain. So, okay, Polkadot, send this message to the other parachain. Let's say, okay, I have my Pepe on Moonbeam, and I want to send it to Astar. Okay, Polkadot, send my Pepe to the other chain, to Astar, and then it gets sent. But this is right now how it works, because right now this is current in development, and how this will look is it will be direct connection between all parachains. So the Polkadot relay chain will only be for security. This is it's very hard to understand, and parachains will be able to communicate between themselves. It's very new. It's still in development, but it's quite cool. So this was something native on the blockchain. So that was very secure, very safe, but it only works for Polkadot because they have developed it for it. So what is GMP? GMP, it's general message passing. And this is on a nutshell. So you have one blockchain, you have another blockchain, you send a message, something happens here, and then the message is written to the other chain. Looks easy, looks nice, the concept is quite straightforward. I have Pepe, I want to send it, please send it to me, and I got it. That's pretty straightforward, okay? But this is how it really looks. And this, this is a solution that it's called Wormhole, okay? Wormhole is one of the most popular message passing protocols. And how it works is like on the middle, you have something similar to a blockchain. It's called a decentralized network. I won't go very deep, but you have this kind of guardians that every time that you send your Pepe to the Wormhole contract, they are validating that there are new messages there. So, okay, I send my Pepe to Moonbeam, and it's here. So there's this guardian network that are validating that this happened, and they generate like a receipt, a very favorable, very favorable proof. So signet BEA. And what it does is it has some kind of like listeners. It's people like, okay, there's a new BEA. Okay, it's okay. Now you can send the message here. So what you are doing is, okay, send it. And when Wormhole like generates the cryptographic proof, you can get it and put it on this chain. So you call a function on this program, and as an input, you add this verified proof, and you get your Pepe on the destination chain. This was like a very quick explanation of what is Wormhole, because it's a very deep topic. if you want to really know how to implement it and how does it work, their documentation is really good. And on Moonbeam, on the Moonbeam documentations, there are also like examples on how can you code this. Like, okay, you have a blockchain and you have another blockchain. How can that do this? And you implement this, and you implement this, and you do this, and it's quite cool. So, but this is one that it's Wormhole, and just to put in comparison to another one that is also really cool, and the style is different too, it's called Axel. So what is Axel? So Axel, it's a blockchain, okay? So what they do is like, okay, you have this computer node, you install a software in your computer, and then you are an Ethereum node. And you can do the same for the rest of blockchain. So what Axel does is, okay, you install our software from our blockchain, and if you want to do cross-chain messages, you can install the nodes from the rest. So for example, you have an Axel node, then you have an Ethereum node, you have a Moonbeam node, you have a Polygon node, and then you can like send messages to different networks. And what you do is, for example, this is me. This is me after 20 hours of coding. So you see, I'm just bold, okay? So I'm on, for example, on Ethereum, and I have my Pepe. And I want to send my Pepe to Moonbeam. So what I do, I pay some gas to the Axel gateway. It's like, okay, I need to send this message, but I need to pay for the transaction on the other chain. But I don't have the money. So what I do, I send money here, and then I send the message. So let's say I send you €1 for the transaction, and then I want to send 10 Pepe to the other chain. So what it does is you are doing this, and then the Axel network, what it does is wait until the transaction is done here. They have their own consensus or their own way of getting an agreement of what is good and what is bad, and then they send it. It's pretty similar. It's pretty similar. I mean, the difference, it's more or less technical. So on Wormhole, you decide who pays the gas, so who pays the transaction, and here you use the gas services from Axel. It's used in a very on the top, because if we go deep, I mean, Axel can be very tough. So we got to the good part of the speech. So what is Moonbeam? Okay, so Moonbeam is an Ethereum-compatible smart contract parachain of Polkadot. So there's a lot of fancy words there. Let's just go one by one. Ethereum, this kind of blockchain that allows you to have programs, and you can have these cool financial services, applications. And that's why it's a smart contract. Parachain is how the blockchains inside Polkadot are called. It's just another fancy name. And Polkadot, I already told you this, blockchain of blockchains. So the first thing about Moonbeam is that it's built with Substrate. That what is Substrate? It's the tool from Polkadot to create blockchains. It's a modular framework that it's also a very cool word, but what it does is like you have a blockchain that it's like the basic layer, and you have different modules. And you can get these modules and plug it into your blockchain. So let's say I want to have Ethereum on my blockchain. I'll put it. I want staking. I want governance. So you can just connect it, like if it was a Lego, and then you can build your own blockchain. And that's super cool because there are very different blockchains on the Polkadot ecosystem that also has an EVM, but also has this Substrate part where they can do whatever they want. And another thing is that Moonbeam has 12 seconds finality. It's soon to be 6 when there's some improvement on Polkadot. And what's finality? Finality means, I mean, the moment on when, for example, you do a payment. When is that paid? When you click on the button, when the bank says it's okay, when the bank does the processes on the background. So that's finality. And why do I mention it here? Because if you go to investigate to Ethereum, you will see that the scalability solutions or the interoperability solutions from Ethereum say that they have very low finality, like 2 seconds, but that's soft finality. What does this mean? Because these other blockchains depends of their finality to Ethereum finality. So that's a soft finality. And for Crosschain, you need, I mean, to send the other transaction, you need to be sure that the transaction on the origin chain has finalized. That's what's called finality. And that's why it's important to have a low finality to do cross-chain, because to be able to send information on the other blockchain, you need a low finality. And we are just speaking about one blockchain to the other, but what if you need to send a message to multiple blockchains? Then that's important too. So that's a very good point. And the Web3 RPC support and unified accounts, it's maybe a very technical thing, but Web3 RPC support means that we are completely compatible to Ethereum, because with Ethereum blockchain, what you do to interact with it, it has an API, and then you interact with this API. It's from code or directly just with commands. It's quite cool. And the unified accounts is because on Polkadot, there are a different amount of, I mean, there's a different kind of accounts, and the account is something like an hexadecimal address, like 0x, blah, 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 blah. This is on Moonbeam, on Ethereum, and on Polkadot, it's way different. So what happens with Moonbeam is that you used to abstract all this substrate part, because learning Ethereum, it's already hard. So imagine just learning more stuff. So what Moonbeam does is just abstract all these new features into Ethereum. How does it? So substrate and Ethereum. So as I said, it has an Ethereum API, Moonbeam. So if you are an Ethereum developer and you already have code, you can just deploy it to Moonbeam. It has a substrate API that this is way more complicated, but it's also way more powerful. Because, for example, when it says governance, for those that are not familiar with blockchain, this means that to make improvements on the blockchain and to do like decisions on the blockchain, you need the token and you need to vote. And it's on chain, so it's not only about sending money, because, for example, blockchain is nice to send money because it's something that you need to be, that you don't want the people to lie with money. The same with votes. So it's a very good thing, and one of the good things about Moonbeam is that you don't need to force all the computers like to follow the rules when there's a new update, because if the governance, if it's approved that there will be a change, there will be a change, and then it updates. So it's something that it's super cool. But what happens that this substrate API, it's hard to understand, it's hard to use if you are used to another technologies, because it uses, I mean, it's built in a new language called Rust, like the video game. So if you go to YouTube and put Rust, most probably you will see the game, and then you see the language. But this language, it's very good. So to access these substrate features, Moonbeam has something called precompiles, that on the blockchain wall, what precompiles are functions, or functions that work outside of the normal flow of this Ethereum virtual machine. So because, for example, for the Ethereum virtual machine, every line of code that you write costs money. So the less codes of line that you write, the better. So these precompiles, I mean, what it does is allows to do hard stuff. For example, exponential multiplication. That it's, I mean, it needs a lot of computation. So you do it outside of like that part of the blockchain and put it there. This is super technical. But what this kind of allow, and what this precompiles allows you to do, for example, on the normal Ethereum, you cannot batch transaction. I mean, you can on the program level, but if you're a user and you want, for example, approve a token and send it, you need to do it in 2 transactions. Here on Moonbeam, using this precompile, you can use batch this transaction in 2. Or for example, let's say I want to sell Pepe, buy USD, and buy Glimmer. You can do it in 1 transaction instead of 3. This is pretty cool. And the call permit one, what it allows you is to pay the gas for another person. So this is also super cool. But this is, I mean, this is like very deep, very technical, and the important one is this one. That we have, I mean, Moonbeam have precompile like a predefined function to do cross-chain messaging. And why is this, I mean, why is this important? I mean, I don't get it. So because of this. So this is what Moonbeam calls rotate liquidity. And they use Wormhole for this, the one that I explained about general message protocol. And what does this allow? So Moonbeam, why is it important on this multi-chain wall and on all this interoperability wall? Because it's the door to Polkadot from the other chain. So for example, if you have liquidity to Ethereum and you want to move them to Hydra, you can go to an application called Carrier. And on Carrier, you select the destination chain, you select Hydra, and just with one click, you go from here all the way around to the other side. Using token bridges and all this stuff, you will need to bridge your assets from Ethereum to Polkadot, from Polkadot to Moonbeam, and to Moonbeam to Hydra, or like 2, 3, 4 transactions. And if you want to do something, I mean, if, for example, if I go to Amazon and I want to buy something, if I cannot have it in 1 click or 2, I may lose the interest. It's the same with this. So you need like something that works, that it's just a few clicks, and Moonbeam, what it's accomplishing is this like infrastructure so the apps can just have money, liquidity from different chains. That's one of the problems of a multi-chain ecosystem, like it's becoming blockchain, because right now, let's say you have 1 million in one chain, another million on another chain, and another million on another chain. I mean, right now, if you will be able to have all that liquidity at the same time, you will have 3 million and not 1, 1, 1. And why would you want to have more millions? Because if you want to swap more amounts of money, you get better prices for this pool stuff that I told you before, that you need to have an equal amount of tokens. So this is one of the uses of Moonbeam for the cross-chain interoperability. So they use Wormhole for the external blockchains and XCM for the internal ones. So it's using 2 different cross-chain methods in one transaction, just 1 click. It's super cool. And just to end up, this is the last protocol we will speak about. It's called Prime Protocol. And it's very similar to Moonwall, the one that I said on the second slide about what it's at the app. Because what it does is just, it uses Moonbeam as a hub. So for example, let's say that you lend money on Arbitrum, and you want to borrow Ethereum on Ethereum. Then you will use Prime Protocol to use your assets that are used to deposited here to borrow money on the other chain, and just with 1 or 2 clicks. And this is really awesome because you can tackle different liquidity, different kinds of money, with a few clicks. So that in the normal blockchain space, you need to do a lot of clicks and a lot of movements. So this was everything. I think I spoke a lot. Hope you liked it, and if you have any questions or anything, you can just drop it to me, or if the questions come later to your mind, you can just message me on Telegram or on LinkedIn, just Ismael Bautista, and you will find me, or just here. Thank you. And that's it.
Maybe 1 or 2 questions.
If anyone has, Jenny?
So you know that this Polkadot drama happening in Treasury right now, and my question, what do you think, whether Polkadot will be still alive in a year, and what do you think, how this drama will evolve?
Okay, that's a very good question, and it's a spicy question because, for those that who don't know, Polkadot also has all this governance stuff, and we had one system, and now we have changed it to another one that is called open governance. And there's a lot of drama because now anyone can participate more than before. And what's happening if anyone can participate in an ecosystem that you can ask for money? That people is asking for money for stuff that you may be okay with it or not, but it's a lot of people asking for money on the same page. So my opinion is that it's not, I mean, Polkadot is not in as so bad situation as it looks like, that Twitter creates more drama than it looks like, and that there has been worse stuff than OpenGov on Polkadot, and we have evolved from that. For example, Parity had a very huge hack on the start that has a lot of money hacked with the Ethereum wallet, and then they were still able to keep with the Polkadot development. And also because right now parachains are really starting to deliver. So because all the parachains, I mean, most of the parachains started on the bull run, then all the money got right now. We had Luna, we have a lot of black swans. We really got affected on Polkadot, also on Moonbeam. But I mean, I think that if Polkadot didn't have not died yet, I think that it's very hard because it's very well positioned right now. Not only, I mean, from the public space, maybe it looks very bad, but on the business level, I see that a lot of companies trust on Polkadot technology. Like I saw several companies and state-level companies that use Substrate, and it's like, what the fuck? You know, how? I mean, and why is not on the Polkadot page? That it will be super, super great. So yeah.
Tricky thing that this is, just from my opinion, seems to be a bit annoyed with Polkadot, and if you say, I am building on Polkadot, doesn't mean that you get money.
No, that's...
It's a bit harder to rise if you build on Polkadot.
Yeah, because what people know is Ethereum, and that's why it's important, this Ethereum-compatibility and this interoperability. Like, okay, maybe Polkadot is not attractive, but it has very cool features that can really that can improve Ethereum. Not it's like it's not a fight. I mean, we are all on the same boat of decentralization and getting the control over our money and our application. Have opportunities for ourselves. That's why of the mottos of crypto, like, hey, if you are like motivated enough, if you are incentivized enough, you will do good things. And that's the thing that things with crypto is like what I think about the state. I mean, why the state hasn't fallen yet? Because there's people that really has a sense of a state, and they do very well their job, same as in blockchain.
I think one thing is if check if Parity will have enough money to fund the development, because it's not easy to rise from external VCs. The other thing is that Substrate is going to be implemented in other
Chains.
Ecosystem beyond the Polkadot.
Exactly, like Cardano.
See.
Yeah, and it's something that is super cool, because what does this mean? That someone that learns XCM will be able to use it on another chain. So what does this mean? On the blockchain side, that it's better interoperability and safer, as I told you, because it's native to the protocol. And on the other side, the people that is interested on this stuff will have more opportunities to have a job, because it's something that it's really passionate. I mean, I really like this stuff. I have in the personal level, I have my own job. I'm an IT service desk, and I fix computers and all this stuff. And on my free time, I do this stuff. I code, I develop, I present myself to hackathons, and this grant committee stuff was on my afternoons. Like, hey, I don't have free time, but I really like this stuff because I learn, I earn money, I get inside, I get motivated. You know, and this is something that with blockchain, that is what I want to share with the people, with the young people. Hey, it's something that it motivates you. And if you like something about coding, it doesn't need to be blockchain. It can be AI, but you need to go for it. And if you keep working on it, and your intention is not to directly earn money, but to generate something like earn personal value or create a product, then you will enjoy and you will earn money. That's my tip on this blockchain stuff for the young people. And for the not young.
1 second before the next question, I want to try to see if that microphone works.
Oh yeah, for the questions, that's true. Oh yeah, your questions might not have been here.
The answer was quite versatile, so everyone understands what was asked, I guess.
I hope so.
Hello. Yes, it works. Hey, magic happens.
Magic happens.
Who has the next question?
That's why we have technology behind you. That's why we have technology, because.
Okay, so why do you think some people might relate the blockchain or Bitcoin technology to criminal-related stuff, like buying illegal stuff, even if it's very traceable and it's open to the public, so everyone can see it? But I don't see how.
That's a very good topic. That's a very good topic and a very good question. So to put you in context, there's a cryptocurrency called USDT that it's a version of the dollar on blockchain, and this USDT is like the most. I mean, the amount of all the dollars that are on blockchain. I mean, not all, but the vast amount is USDT. Okay. Okay.
It's a stable coin, right?
Yeah, sorry?
It's a stable coin?
It's a stable coin, right. Usually it's a stable coin. And what happens with this stable coin? That there's a blockchain called Tron, that is from a guy called Justin Sun, that they say that, well, people say that all this criminal stuff, it's happening there with USDT. Of course, there's outside, but I mean, demonstrated is not that much, but I mean, we all know that you cannot demonstrate this. But if you get the amount of money that it's moved by crypto, the amount of money that it's moved on USD, you see that the amount of crypto that it's used for criminality compared to the normal money, it's way worse. And what happened, for example, I was like trading a lot when I started on blockchain, and what people trade, it's called shitcoins, this Pepe, this Doge, and all this stuff. So what happened? There was a lot of people creating these fake coins and getting all the money and running away. What happens that you move, for example, to Binance, to Coinbase, and that people gets caught. There are some news. I mean, if you look for Binance stolen money or something like that, you will see that a very high percentage of the money that is stolen inside the blockchain, it's, I mean, they cog the guys.
Yeah, actually, so earlier we were talking about like hacks.
Yeah.
And actually, that's also why a lot of the hackers, even when they're successful, maybe they steal like $100 million or whatnot, they return the money because actually in practice they cannot use the funds, right? If they want to use the fund, they would need to sort of wash the money, which is possible, but still then they would need to cash out. So they would have to go through a centralized exchange like Binance or other.
Yeah, I mean, unless you are
from when that transaction happens, when they send any amount, even if it's only a tiny amount, that's when they get caught, right?
Yeah, exactly. So this is, I mean, this washing stuff, it's only possible in countries that are, I mean, that doesn't commit to any kind of legality regarding this.
So cash is king, actually.
Cash is king.
If you want to do illegal stuff,
exactly.
It's much easier with cash than with crypto.
Yeah,
nowadays.
because that happens for normal people like us. If we stole, we go to Binance, and when we get to Binance, it's like, clack, we got you. We got liamsi.eth, that it's my name on the blockchain there in jail. So, yeah.
Any other question?
Yeah, did I answer your question?
Yeah, it was.
Okay.
It was good because, yeah, I usually hear people like launder money there or buy legal stuff, but
yeah, but it's like with it's like with everything. Like for example, trafficking with drugs. Yeah. I mean, I remember knew that a guy made a guitar of cocaine. Oh. Like, what the fuck? Like, how? And it was a real guitar. It was made of cocaine. They painted and all this stuff. You know, like, they will find a way. If it's possible, like physically. Yeah. You can. That's why we need blockchain. So, if you steal, we know the people that steal. So thank you for the question. Yeah, thank you. There's a question there.
Can
you? Yeah, the question is like all this amount of blockchains that we have right now in the market. For you, which ones they are building a real tool that gonna be like strong in the future? So
something that it's worth something for people.
That's gonna worth for example like Ethereum, Cardano, so all this kind of blockchains just like name, if you can name like 5,
Okay,
6,
okay, I
7
get what you mean.
blockchains
Okay,
that
okay,
they're
what you
gonna
mean.
be strong, that their people are really doing a good job.
Okay, that you mean that they're gonna deliver a product, let's say. Okay.
Give us financial advice.
Yeah. I mean,
Like that,
if
because
Ethereum and all the Ethereum related ones, and that's on the public blockchain space. And on the private blockchain space, I mean, I think, for example, that Polkadot, Cardano, and Avalanche and Polygon, not in that order, just
yeah, that's
are doing
better
I mean, but as a business, they are doing it really good. And basically, to be alive and to finally deliver a product, that's what you need, right? And then Cardano, it's a very big company. They have their Cardano in Africa. They have their agreements with Egypt and all this stuff. Ethereum, because it's the base of all the public blockchain.
So they already have all that reputation. Maybe
they have the reputation, they have the tool, they have the developers, and it's, I mean, not like they in the terms of there's like it's an Ethereum, it's the Ethereum Foundation. Like, for example, me, I'm very fan of Ethereum, but I don't care if it's Ethereum or on another chain. For example, me, I'm very fan of Moonbeam. I mean, that's why I'm giving this talk instead of just staying at my home. So, I mean, I would say Moonbeam, Polkadot, I mean, Ethereum, Polkadot, and whatever that Cardano, Avalanche, I mean, whatever that you see that it's looking on the future in the terms, okay, we are delivering infra, and we are doing infra, because basically they are just infra providers. Exactly. And the application is something that we are doing. Why Ethereum has so many apps? Because it was first, and then the people is really interested in it. Then, for example, there are other chains that doesn't have.
And the programming language that people, like the main programming language, if someone wants to...
if you want to learn blockchain, JavaScript, Python, Solidity, and Rust.
No Java.
No Java. I'm not
Zero.
there. I mean, no, you can. I mean, it's a good tool, but more for private blockchains.
Okay.
Yeah, that's something.
I mean, for example, like, Java is much more like powerful than Python, and why Python and Java?
Yeah, no, for example, because there are already more libraries for it, and there are more tutorials. So if you're learning, it's better. Java, it's more like, for example, you want to build a blockchain at Microsoft, you want to build it on Azure, and you want to like use Hyperledger Besu or something like that, and that's more Java-like.
Okay.
That's okay. So.
All right, thanks again.
Thanks again. The questions were awesome. The questions were better than my speech. So thank you, everyone.